Hello everyone, in today's video we are discussing about the non-inverting terminal schmitt trigger. So non-inverting schmitt trigger, we are giving the input to the positive feedback, that is non-inverting terminal, and we are giving the negative terminal to the ground, and where we are giving the input it is only becoming the positive feedback. So how it is working, let us see. When the sine wave is positive, we are getting output is also positive. When the sine wave is negative, that is in the lower triggering point, the output is also in a lower triggering point. When the sine wave is again UTP, the output, that is it will be in UTP only. So we can say when the sine wave is positive, we are getting positive output. When the sine wave is negative, we are getting negative output. So as it is non-inverting terminal input, it is given that positive input will give positive output, and it is given negative input will give negative output. So by seeing this, we'll see how the output we are going to assume. So we can tell that here this so here we can say that this voltage reference, so voltage reference what we are getting, it is across the, yes, it is across the voltage output connection. So we can say that this is voltage reference is equals to, so this voltage reference is equals to V0 into R2 divided by R1 plus R2. So this part is called as VR. Okay, voltage reference. And what we'll get for UTP, so UTP is nothing but our Vin. Vin is nothing but what Vin is connected, it is connected to voltage reference. So we'll get as I2 into R2 UTP. And now current through R1 is I1. So we can say that, so current is flowing same throughout that, so we can say I2. So V0 into I2 into R1, that is current flowing through the voltage output, will get V0 divided by R1. So we can put this I2 value, so I2 value we can put yes. So here put equation 1. So UTP is equals to, instead of I2 R2, what I can put, V0 by R1 into R2, or else I can put plus Vsat. Why I am putting plus Vsat? This UTP is nothing but one part of the sine wave. So we'll take at that point where it was, it is plus Vsat saturation, R1 into R2. Similarly for LTP, it is minus Vsat divided by R1 into R2. So here also we will get the difference between UTP and LTP is V hysteresis is equal to UTP minus LTP, which gives us R2 Vsat whole divided by R1 minus what is our LTP values, minus Vsat into whole resistor 1. So we'll get R2 Vsat plus Vsat into R2 whole divided by R1. Yes, we'll get this. So we can say we are getting 2 R2 divided by R1 Vsat. So V hysteresis is equals to 2 beta Vsat. Equation 5. So we can say this equation. Yes. So here we have how when we are solving the problem, how we are using these formulas. So when it is inverting terminal, we are using the R2 value, R1 value has triggering voltage, that is UTP or LTP value whole divided by I2 value, and R1 equals to V0 minus UTP or LTP trigger voltage whole divided by current flowing in it. And sometimes we assume R1 is equals to 1 kilo ohm when the bipolar op amp is working, and V0 is equals to 90% of the supply of plus VCC or minus VCC. Similarly, non-inverting terminal, so we have R2 is equal to triggering voltage by I2, that is triggering voltage is nothing but your UTP LTP value, and I2 is equals to 50 microampere, that is R1 into V